When we hear the term breakdown maintenance, many people immediately think of it as something reactive, random, or even outdated, a system we just use until we can apply preventive maintenance. But the truth is very different. In this episode, we'll take a closer look at breakdown maintenance as a core strategy, not just a backup plan. It's the foundation on which all other maintenance systems were built, and it still plays a critical role today in almost every factory, no matter how advanced. Today, we'll focus on how to improve the performance of breakdown maintenance by reducing MTTR, mean time to repair, a key performance indicator that shows how quickly we recover from failure. This episode is for two types of maintenance professionals: those working in environments where preventive maintenance is not yet possible and those who already apply preventive maintenance, but may overlook the ongoing value of reactive maintenance. Let's get started. The goal of this series is to correct common misconceptions about maintenance systems, how they should be used and implemented within organizations. We'll also gather and explain the most important information that every maintenance professional needs to know, especially those working in companies that may not fully recognize the value of maintenance work, companies that fail to allocate the right budget or resources for proper maintenance operations. This series is also designed for professionals who have already implemented planned maintenance systems but didn't see the results they were expecting, whether in terms of equipment performance, technical KPIs, or in terms of cost reduction, financial KPIs. Finally, this series will serve as a reference and data bank for maintenance managers and other departments looking for reliable performance indicators to measure and compare their actual maintenance results, and use that data to drive real improvement. Now, let's take a closer look at the definition of breakdown maintenance, a term that many people use but often misunderstand. Definition 1. The practical perspective. A simple and practical definition of breakdown maintenance is this: it's the work you're doing today that you didn't plan to do at least a week ago. In other words, it's unexpected. Something broke down and now you're forced to fix it, whether you like it or not. Definition 2. The operational view. Breakdown maintenance can also be defined as all maintenance activities that are not scheduled in advance and are only performed when equipment fails. This includes emergency repairs, urgent part replacements, and any unplanned interventions triggered by equipment failure. Definition 3. The technical description. From a technical standpoint, breakdown maintenance is maintenance that is carried out on equipment that has stopped working, experienced a fault, or can no longer operate within its expected limits. In short, the machine is down, and the goal now is to get it back up and running as fast as possible. Summary. While the wording may vary, all these definitions point to the same core idea: breakdown maintenance is reactive. It happens after something goes wrong, and it often leads to high costs, production delays, and stress on both the equipment and the maintenance team. That's why it's important to understand it deeply, measure its impact, and, when possible, reduce our dependence on it. In the previous episode, we explained that maintenance systems are generally divided into two main categories: planned maintenance system and unplanned maintenance system. As we explained, the unplanned maintenance system is referred to as breakdown maintenance system, although it has several names that differ according to the classification of the type of part, whether mechanical or electrical, and the country and organization, as we will review them all in this episode. Now, when we say maintenance system, it means that there are tasks, execution methods, and performance standards, even for unplanned maintenance system. Unfortunately, many people wrongly assume that unplanned maintenance simply means that the maintenance team will be waiting until part or asset failures and then fixing it. That is not accurate. Before we correct that misunderstanding, let's first highlight a few key points about why unplanned maintenance system is important. 1. It is the foundation of all planned maintenance systems. Without first improving how unplanned maintenance is managed, no maintenance manager will ever be able to achieve the full potential of planned systems, especially in terms of equipment efficiency or technical performance. This is one of the biggest challenges maintenance departments face when trying to improve their preventive maintenance results. 2. Based on global statistics, unplanned maintenance still accounts for 40% to 55% of total maintenance activities worldwide, even in organizations that already apply preventive maintenance systems. This shows how common and essential it still is. 3. Even in world-class organizations, unplanned maintenance will always represent around 10% of total maintenance work. That's why improving the performance of unplanned maintenance systems will always matter, even in companies that have successfully implemented planned maintenance systems. So, unplanned maintenance isn't just about fixing what's broken. It's a system with its own structure, impact, and best practices, and improving it is critical to overall maintenance success. Now, let's talk about the different terms used for unplanned maintenance. You might hear different names depending on the industry, the company, or even the country, but they all refer to maintenance that is not planned in advance. The first term is breakdown maintenance. This happens when a machine or system suddenly stops working, and we only fix it after it breaks down. It's the most basic form of unplanned maintenance, and often the most disruptive. Second term is run to failure, RTF. This is a strategy where we intentionally allow a machine to run until it completely fails. It sounds risky, but it's sometimes used for non-critical equipment where the cost of planning maintenance is higher than just fixing it when it breaks, and in the electrical parts that consist of electronic parts, which will be explained in the next episodes with proactive maintenance. The third term is reactive maintenance. This term is used when we respond after a failure happens. It's like calling the mechanic only when your car stops on the road, no prevention, just reaction. Fourth term is corrective maintenance, CM. Corrective maintenance means fixing a problem after it's been detected, either through inspection or after a failure. It can be planned or unplanned, depending on how early we catch the issue. But in many cases, especially in small factories, it's done only after something goes wrong, which makes it unplanned. So, even though the names are different, the idea is the same. We react after something breaks, and that's what we call unplanned maintenance. Let's talk about breakdown maintenance, and why relying on it too much is considered a worst practice in most manufacturing environments. In general, if reactive maintenance makes up more than 20% to 30% of your total maintenance activities, that's a red flag. It means you're mostly fixing things after they fail, not before. And that comes with serious consequences. Why is breakdown maintenance so costly? Breakdown maintenance can be surprisingly expensive, often double the cost of planned maintenance. And it's not just the repair work that racks up the bill. So, what really makes it so costly? We will try to summarize these reasons in the following points. 1. Additional damage. When machines are allowed to run to failure, they often damage other components around them. 2. Emergency labor. You need technicians to work overtime, on weekends, or overnight. 3. Scrambling for parts. You may not have the spare parts ready, so you spend time searching and often pay extra for express shipping or air freight. 4. Extended downtime. With all these delays, your production line is down longer, costing you even more. And worst of all, in the rush to get production going again, there's often no proper inspection or verification of the machine's condition after repair. As long as the machine can make product, it's declared operational, even if it's just one step away from the next failure. What do the numbers say? Based on practical experience and international studies, one reactive maintenance for general rotating machinery costs about 30% more than preventive maintenance. 2. And it costs 100% more than predictive maintenance. So yes, reactive maintenance will always exist, but it should be minimized, not normalized. Relying on it too heavily is a recipe for higher costs, more breakdowns, and lower equipment reliability. How much of your maintenance is unplanned? Now let me ask you a direct question. What percentage of your maintenance work is unplanned in your organization? Take a moment to think about it. Are your maintenance activities mostly planned in advance? Or is your team constantly reacting to failures, breakdowns, and emergencies? If more than 20 to 30% of your maintenance is unplanned, you're likely operating in a reactive mode. And as we've already discussed, that's costly and unsustainable in the long run. So how do you know exactly where you stand? In the next paragraph, we will learn how to calculate the percentage of unplanned maintenance. Now let's calculate it. As we agreed, the unplanned maintenance system is any maintenance task performed today that was not scheduled at least 1 week ago is considered unplanned maintenance. This definition gives you a clear line between planned and unplanned work, and it's practical, measurable, and actionable. Here's a simple formula you can use. Unplanned maintenance ratio % equals corrective maintenance hours times 100 divided by total maintenance hours. Let's take a real example. Imagine that in 1 month, your maintenance team carried out 80 jobs in total. Out of these, 30 were unplanned, meaning they were not scheduled at least 1 week in advance. Now plug that into the formula. 30 unplanned jobs divided by 80 total jobs multiply 100 equals 37.5%. That means 37.5% of your maintenance was unplanned, and that's higher than the recommended range. According to best practices from leading global manufacturers, your unplanned maintenance rate should ideally be under 10%. Above 30%. You're definitely in the red zone. But don't worry, you are not alone. Did you know that most organizations, based on statistics, suffer from an increase in the rate of unplanned maintenance? Conclusion. So, if you're not already tracking your unplanned maintenance ratio, start today. Because you can't improve what you don't measure. Why is your unplanned maintenance rate so high? Causes behind reactive maintenance dominance. Let's now talk about a critical question. Why is the percentage of unplanned maintenance still high in many organizations, far beyond global benchmarks? Well, in most cases, the reasons are actually beyond the control of the maintenance manager. Many maintenance leaders find themselves stuck between two forces. 1. Upper management that doesn't approve budgets for preventive tasks, inspections, or routine overhauls. 2. And production departments that won't release machines for planned maintenance at the right time. 3. At the same time, these managers are constantly pressured to cut costs, without a clear understanding that cutting maintenance expenses doesn't necessarily reduce total cost. In fact, it often leads to higher costs through breakdowns, overtime, and lost production. Common challenges maintenance teams face. 1. Lack of awareness at the executive level of the real financial losses caused by equipment breakdowns. 2. Inability of production planners to allocate dedicated downtime windows for inspections or preventive maintenance. 3. Use of cheap spare parts based on the false assumption that this will reduce maintenance costs, while in fact, it often causes repeat failures and more unplanned downtime. Full upper management prioritizing short-term savings over long-term reliability, always choosing to delay or cancel preventive work to save money, not realizing this usually increases total cost through reactive work and system inefficiencies. 5. Frequent breakdowns caused by poor operating practices, such as misuse or overloading of equipment by production staff. The result: even the most experienced maintenance professionals struggle to implement effective preventive strategies, not because they lack knowledge or skills, but because the system around them is not enabling success. So if you're a maintenance leader, remember, success depends not only on what you do, but also on how your organization supports what you do. So, your unplanned maintenance is too high. Now what? All right. So now you've done the math. You've calculated your unplanned maintenance percentage, and it turned out to be much higher than the global average. Whether it's 40%, 50%, or even more. You're definitely not alone. Many maintenance departments across industries face the same challenge. Now you might be wondering, is it even possible to eliminate unplanned maintenance? If you cannot access the preventive maintenance system, the honest answer: no, but I will tell you how to improve your team performance. In fact, even in world-class plants, unplanned maintenance still makes up around 10% of total maintenance activity. So the real question isn't how to get rid of it. The question is, how can you improve the way you manage it? That's what we're going to focus on. In the next part, I'll walk you through how to improve your unplanned maintenance, starting with enhancing one key performance indicator that will help you reduce response times and streamline your internal processes. These aren't just concepts. They are proven practices I've seen work on the ground, and they can help you too. Understanding MTTR and MTBF in maintenance performance in any industrial maintenance system, two key performance indicators help assess equipment reliability and the effectiveness of the maintenance strategy. MTTR mean time to repair, and MTBF mean time between failures. MTTR is the average time required to diagnose, repair, and return equipment to operational condition after a failure. A lower MTTR means faster recovery from breakdowns, which helps reduce downtime and maintain production flow. MTBF, on the other hand, measures the average time that equipment operates without failure. A higher MTBF indicates more reliable equipment and more effective preventive maintenance practices. In the unplanned maintenance system, the number of failures is much greater than the number of failures in the planned maintenance system. Therefore, the unplanned maintenance system focuses on reducing the time required to repair faults in terms of organization and preparation MTTR. In this episode, we will focus specifically on MTTR, as it is one of the most critical outputs of unplanned maintenance. Reducing MTTR can bring significant operational gains. Even if failures can't be entirely avoided, a fast and efficient response can keep the production line moving. Together, MTTR and MTBF provide a powerful insight into both equipment health and maintenance team performance, and improving these numbers is the foundation of any high-performing maintenance strategy. Here I am showing two charts that compare two different maintenance strategies: breakdown maintenance versus preventive maintenance. In the first chart, which represents unplanned or reactive maintenance, we can see that the number of breakdowns is high. This means the MTTR, mean time to repair, is also high because the machines stop frequently and take time to repair. At the same time, the MTBF, mean time between failures, is low because the time between each failure is short. It's like a heart monitor showing irregular and weak pulses. The system is unstable. In the second chart, which represents a preventive maintenance system, the breakdowns are fewer. This results in a lower MTTR and a higher MTBF, meaning the machines run for longer periods without failure. The system is more stable, like a steady and healthy heartbeat. So the goal is clear. By shifting from unplanned maintenance to preventive maintenance, we can increase machine uptime, reduce downtime, and improve overall production stability. How to improve unplanned maintenance performance: real-world practices. Now let's talk about real solutions. If your unplanned maintenance rate is too high, you might not be able to eliminate it, but you can make it faster, more efficient, and smarter. Based on real factory floor experience, here are practical steps you can apply immediately. 1. Emergency toolkit ready and mobile. One of the biggest time wasters during breakdowns. Technicians running around looking for the right tools. Solution: keep a pre-packed, mobile emergency toolkit with all standard tools, testers, etc. Check it daily. Assign responsibility. Make it non-negotiable. 2. Track recurring failures. Act on the data. Look at your breakdown history over the past 3 to 6 months. What's coming up again and again? Once identified, train your team to diagnose and repair these quickly. Even better, prepare checklists and spare part kits just for them. Many delays happen because the maintenance team can't get access to the machine. Set a clear protocol with production. When a fault is reported, the equipment must be handed over quickly and safely, even if it means minor production delay. 3. Critical spare parts, fast access shelves. Keep spare parts for high-risk equipment in a clearly marked shelf or drawer. Use color codes if needed. No more searching, no more store delays. 4. Rapid notification channels. Don't rely on slow paper work orders for emergencies. Set up a WhatsApp group, radio channel, or even a Google form for instant fault reporting. Simple beats perfect. Speed matters more. 5. Pre-assigned roles during each shift. Each shift should have a clearly assigned first responder, the technician who jumps on the issue immediately. Others follow with tools, parts, or assist. No confusion. No debates. Just action. 6. Stronger coordination with production. Many delays happen because the maintenance team can't get access to the machine. Set a clear protocol with production. When a fault is reported, the equipment must be handed over quickly and safely, even if it means minor production delay. 7. Document every breakdown and review weekly. After every repair, document what happened, even in bullet points. Then spend 15 minutes each week as a team reviewing the top 3 breakdowns. What went wrong? What could have been done faster? It builds team awareness and skill. One factory I worked with saved 17% of their average MTTR using this simple practice. Remember, the purpose of any maintenance system, old or modern, is to increase uptime and reduce repair time. And while planned maintenance is ideal, unplanned maintenance will always exist. Now that we've explained MTTR, MTBF, and discussed the 7 key points to reduce repair time, now let's see how these same principles transformed one of the fastest-paced industries in the world, Formula One. Let's look at this real-life example from Formula One. What you're seeing here is a pit stop. The team is changing the car's tires in just a few seconds during a live race. In this video, we'll explore how reducing repair time, MTTR, isn't just about speed, it's about structure. You're now watching the evolution of Formula One pit stops, a real-world example of how planning and teamwork reduce downtime. In 1957, a tire change could take over 60 seconds. By the 1980s, it dropped to about 25 seconds. In the 1990s, it fell again, around 8 seconds. By 2000, pit crews brought it down to under 4 seconds. Today, top teams complete a full tire change in under 2.5 seconds. This wasn't magic, it was process. What changed over time was toolkits became optimized and mobile tasks were tracked and reviewed after every race. Spare parts were ready and accessible. Instant communication systems were used. Team members had clearly assigned roles. And everyone practiced, again and again. The same 7 principles you just saw. This is not random. It's the result of extreme preparation, clear role assignment, tools ready in place, standard procedures, and perfect team coordination, exactly the same principles we discuss. In maintenance, we may not work in a racing track, but the concept is the same. If we want to reduce MTTR, we need to act like a Formula One pit crew. Everything must be ready before the failure happens. Everyone must know what to do without delay. That's how you win races in Formula One, and that's how you win time and money in production. In both Formula One and factory maintenance, every second counts. A fast, organized response reduces downtime, saves money, and sets top-performing teams apart from the rest. In conclusion, I would like to emphasize the following points. 1. Unplanned maintenance is a system in which the maintenance department is responsible for reducing repair time by developing plans, rather than waiting for breakdowns to occur, as is commonly believed. 2. Planned maintenance systems will remain in place regardless of the level of maintenance implemented by organizations. 3. The increase in the rate of unplanned maintenance is not usually due to a lack of qualified maintenance personnel, but also to a low level of awareness among senior management of the importance of maintenance. 4. Maintenance performance efficiency can be increased by implementing unplanned maintenance objectives that reduce repair time. To wrap up this episode, I want to emphasize one key message. Breakdown maintenance is not a weak or outdated system. On the contrary, it's a fundamental part of maintenance history, and it still plays a critical role today. In this episode, we've seen how we can improve the performance of breakdown maintenance, not by eliminating it, but by reducing the mean time to repair (MTTR). We discussed how MTTR is not just a number, but a powerful performance indicator that helps us measure, monitor, and improve our response to failures. This episode is especially dedicated to two types of maintenance managers: those working in organizations that are not yet ready to implement preventive maintenance systems, and those who already apply preventive maintenance but may overlook the continued importance of reactive or breakdown maintenance. Thanks for watching and stay tuned. Ready to optimize your operations and reduce production costs?
Let's talk.
Contact us HM Berlin for Engineering GmbH Precision.
HM Berlin for
Performance,
Engineering GmbH
Progress,
Precision.